Lesson 4.5, Video 1. Now here we're looking at a binomial being squared. So we have to get comfortable with one important piece of notation. We know that if I say a squared, that's the same as a times a. Now that's important. It seems simple, but that piece right there is what we must understand in order for us to handle what's happening next. Now we've done multiplication of binomials before, where you would have a situation in which you would use FOIL. So for example, x plus 2, x minus 3, and you would FOIL it. But if you happen to have a situation where both binomials that you're multiplying together happen to be the same thing, then you can actually write that as x plus 2 quantity squared, because there's two of them and they're exactly the same, just like we do right here. So if you understand that, then you can understand a square of a sum. Now this is kind of fancy to understand right here, so I'm just going to bypass that for a moment and we'll come back to it. That's for people who like shortcuts. But let's take a look at what this means right here. Now, this statement is the same as x squared, meaning that I could write it as x times x. Now, if that's the truth, then I can write this binomial squared as 3x plus 5 times 3x plus 5. There's two of them. Now for the record, 3x plus 5 quantity squared does not mean that I should distribute the power. Okay? That is imperative that you understand that. Now if I had 3x squared, in other words a monomial, then yes, I would distribute the power. But the difference in the two things here is that one of them, this one, is a binomial. And when you have a binomial or a trinomial, in other words anything but a monomial, you cannot distribute the power. It is only when you have a monomial raised to a power that you can distribute the power. And that is the difference. So if we have a binomial being squared, we must write it this way. Which leads us to say, oh, I have to actually distribute these two binomials. And I've seen those questions before. Which is a FOIL. So first times first, outside, inside, and last. So we have 9x squared. We happen to have two like terms, so we combine them, and this is our finished answer. So, next one. In reflection, can I do this? No, you cannot do that because of the addition. So we are not allowed to do a distribution of powers here. What we are to do is to understand that this actually means 8c plus 3d twice. There's two of them, which tells us that we are to FOIL. And we get 64 c squared. Outside is positive 24 cd, they're different terms. Inside is plus 24 cd. And last is 9d squared. These two happen to be like terms. They are all degree 2's because C times D, for degree description, we call them, we add them up, remember? So our final answer is 64C squared plus 48CD plus 9D squared. No like terms, in order, and this in reflection is what they try to state right here. When you have the same two things being FOILed, then you'll have the first term with the square, the second term will be squared on the end, and you're going to have twice as many as the multiplication of the two terms, which doesn't bother me if you understand that. That's a shortcut if you want to get more interested in something like that. Longhand, though, will get you there every time, as long as you're careful with your calculations. This ends Lesson 4.5, Video 1.